All right, so it's 11 o'clock, so let's go ahead and get started. Welcome to CS 352, Systems Programming in Unix. My name is Daniel Dickin. I'm the instructor for this course. You can just call me Daniel. You don't need to call me anything special. Before we begin, I wanted to print out a class list and get everybody's names, but I completely forgot to do that. So if we just go around and just say your name real quick, that'd be great. So we'll start with Brian. Who's your TA?
I'm your TA, guys, and my name is Brian. I'll be grading everything.
Just start over here.
I'm Abby.
I'm Javier and I'm a contract.
Okay. My name is Daniel. Nice to meet you.
Mason.
Mason. Can you just say your name real quick?
Veronica.
Veronica.
Josh.
Josh.
Jesus.
Jesus.
Danny.
Say it again.
Danny.
Okay.
David.
David.
I'm Adam.
Adam. Say it again. Can you say your name? Okay. Just out of curiosity, if you are in the online section, can you just raise your hand? Okay, cool. Sweet. So, yeah, we'll just go ahead and get started. We'll go over the syllabus, and then we will start into the slides on Unix today. So, first we have the course description. So in this course, we are going to talk about introductory Unix topics, shell commands, programming, how basically to develop in that environment. So that'll be this first week, maybe week and a half of the course, and then the rest of the course will just be talking about programming in C, how to become efficient at that, because my goal for this course is to essentially have you guys prepared for the 400 level classes where you'll be doing a lot of C programming. So prerequisites, 127B, hopefully you guys all have that. This is my information. Can you guys all read this off the screen? Okay. So this is my information, my email. My office is on the 7th floor. That's Brian's information, his office hours and everything. So I highly encourage everybody to come to office hours. If you ever have any questions, to send email, post on Piazza and everything. For the online students who are watching this, obviously you might not be able to make my office hours, so I will hold Skype calls or any other online communications if you'd like. That goes for you guys too, if you want. It's not just them, but that is there. Main communication will hopefully be through Piazza, and then here's a link to the course homepage, which it's just a CS website, and this is where I'll be posting, like, syllabus is up here. We have the first assignment directory with the spec and everything is in there. So any questions so far? Yeah.
I've got a 2:45 at noon. Is it okay if I leave at noon?
Sure. Yeah. Because of the online section and everything, attendance isn't required. So
Okay.
if you don't want to show up, I guess that's fine. But I would encourage you to. We will have 4 lectures a week from 11 to 12:30. Like I said, I encourage you guys to come. You don't have to, and I encourage the online students to watch the lectures and ask questions on Piazza if you have any. Again, there's the course objectives. So, preparing you guys to be efficient C programmers for harder classes and knowing how to develop in a Unix environment. So, let's see. If you registered for this class late, you can talk to me about it as far as assignment making up, but that shouldn't apply to anybody in here. And then here we have the assignment schedule. So we are required to write up a little schedule, or a rough schedule at least, for when the assignments will be and what they'll be about. So if you ever have any questions about that, you can look here. And I also have the dates for the midterm and the final. So the midterm will be on July 11th, which is about halfway through the class, and then the final will be August 9th. If you have conflicts with either of those, please let me know as soon as you can. and we could either work around it where you could take it early, or you could just take it online if you're out of town or something like that. So I want to work with you guys to make it work, but just let me know as soon as possible. Here is the grading scale. So we'll have roughly 8 assignments. 60% of the grade will be coming from those. 20% of the grade will be the midterm. 20% will be the final. It's weighted pretty heavily in all of that. There's not really a lot of variety, but you know, I want you guys to do really well in this course. So if you ever have questions, come and ask me. If you are struggling, I'll extremely willing to help. And I think everybody should be able to do great in this class as long as you try, put effort into it. So here are the topics. So yeah, we have, this week we'll be talking about Unix. Hopefully by next week we'll be getting into C, basic C. And then after that we'll start to talk about pointers, memory structures, talk about memory allocation, and that will be the midterm right after that in the following week. So the midterm will cover all the material previous to that. And then we have more advanced C topics after that, like the preprocessor, and then any loose ends that I might have missed. And then finally we talk about shell scripting, and then the final exam will be comprehensive on everything. So yeah. Any other questions so far? And I think, oh yes, this is an important one. So, Code of Academic Integrity, or cheating. This is a page and a half explanation that I borrowed from another professor, but cheating's not to be taken lightly. Don't do it. I will fail you if I find out that you are cheating. That goes for assignments or on exams. I encourage, if you guys come up with test cases for your programs, I encourage you guys share those, and if you do, please share them publicly on Piazza so everybody can use them. I'm fine with you guys, discussing assignments to the point where you get an understanding of how to do them, but never look at each other's code. Never work on it together. Always try to work on it on your own once you're actually programming, and things like that. There is, right here, there's a point, and where is it? Somewhere in here there's a point I have. Yeah, it is this one right here. So if you finish the assignment and you're just feeling really nice, you want to help somebody, feel free to help them, but don't never dictate code to them. Feel free to, whether this is in Piazza or on person, ask questions that'll help them get a better understanding of the problem, but never flat out say this is the code you should write. And that goes for helping your friend in person or writing an answer on Piazza or anything like that. So, yeah. This is a very important section to read through. I encourage you guys to all read through it and understand it. And also something else that goes with this is malware. So malware is short for malicious software, is any software used to disrupt computer operation, gather sensitive information, or gain access to private computer systems. So we'll be running your guys' code a lot through your assignments and everything. So if you ever include malicious code, that's actually a crime, according to the FBI. So whether it be just some funny little thing you think to, try and delete some of our files or something like that, that's illegal, so don't do it. Yeah, and besides that, I think that pretty much covers everything. Oh, finally, I guess the subject to change statement. So information on the syllabus, other than the grades and absence policy, may be subject to change with advance notice as deemed appropriate by the instructor. I don't foresee anything changing, but it might. So, any questions on the syllabus? Great. Then let's start talking about Unix. So I'm going to try and get to the point where you guys know how to log on to Lectura today, which is the system that you guys will hopefully be developing on this semester. And it's just a machine that the computer science department has made public so that students can log in and work on it. So I hope to get to that point today, and then after we get to that point, we'll talk about assignment 1, and then if we have more time, we'll keep going. So, and I just wanted to point out another great resource that I've borrowed a lot from, but there's a lot more information contained to them, are these slides on Unix, and then later I'll link to the slides that are on the C programming language by William Mitchell, who's another lecturer here. They're very detailed, very in-depth, and if you're just looking to get a better understanding, I'd suggest looking at those. So, yeah. So Unix. First, let's look at how is a computer system organized. So this is a very fancy diagram. So you as a user are trying to interact and do things on your computer, and you interact with your operating system. And how you do that is you either do it through a graphical user interface, which is a GUI, or through a shell. And I'm sure you guys all know what a GUI is. You know, if you use the internet, something like that, you're typing in, that's what a GUI is. How many people in here have used a shell before? Okay. So we'll talk about that more later, but that's essentially an environment where you can type commands in and have the operating system interact with you. So these two these are two ways to interact with the operating system, which might be Windows or Mac or Ubuntu or anything like that. And then finally, the operating system is what communicates with the hardware on your computer. So Unix is an operating system. So Unix exists right here. And Unix already knows how to interact with the hardware on your computer, and you can interact with it through a shell. So, let's see. Yeah, so users interact with applications through interfaces such as a GUI or shell. A shell presents an environment that is easier to interact with the system and operate in. So typically, if you have a shell, there's more utilities that are available to you to do more low-level things, to interact directly with the system, rather than if you're presented with something like Windows, where you don't really have that ability. So then applications interact with the operating system, which knows how to interface with the hardware. So you're interacting with these applications through these means, which interact with the operating system and interact with the hardware. Finally, in this class, you'll learn about shell environments and how to create applications that can interact with the operating system. So we'll be operating in this square here. You guys will be the users. You'll be using a shell, and you'll be creating applications that interact with the operating system. So, any questions about that? Great. So what is Unix? So Unix was developed by this guy named Ken Thompson, who worked at Bell Labs, and he created a tiny operating system that came to be known as Unix. And at the time, there was a lot of companies that were trying to make operating systems. Bell Labs was actually trying to make another operating system called Multics, and it was a multi-user operating system, but it just really wasn't working out that well, and nobody could really get something that could really be a standard for operating systems until Ken Thompson developed Unix. So during the 1970s, Unix gradually grew and evolved and spread into the computer science community. A lot of academia really got a hold of it at first and started building things upon it. It was a free software that people really liked because it was easy to use, easy to modify for their own means, and it really gained a lot of ground in the 1970s. Then in the 1980s and 1990s, Unix became an immensely popular platform for software research and development, and later enterprise computing. So a lot of things are built upon Unix. Mac's operating system is built upon Unix. It's a Unix operating system. It's not exactly a Unix operating system, but it borrows pretty much all the code from it. Yeah. So then today there are various Unix-like operating systems run on everything from tiny devices to the most powerful computers made. You know, like Android's operating system, that's based on Unix, things like that. Just, it's used everywhere. And then finally, there's a lot of command line tools that are built into Unix, and those are available on just about every platform that are used by programmers. So kind of was a baseline for a lot of operating systems in the shell environment to interact with your computer. So again, after its creation, it became a foundation many operating systems were built on. Computer-aided design, manufacturing control systems, laboratory simulations, even the internet itself all began life with and because of Unix systems. Today, without Unix systems, the internet would come to a screeching halt. Most telephone calls could not be made. Electronic commerce would grind to a halt. There would never have been a Jurassic Park movie. So, there's a lot of things that we have today that are around because of the Unix operating system. And who knows, somebody else might have created something else, but a lot of things are based on Unix. So here's an interesting link that just illustrates this point even more. So this is a really big chart. So here, oh, that didn't open how I wanted it to. Let's see. I don't have it here. I guess we can just do it like this. So here we have Unix at the start, which is what Unix was called before. It was UNIX. And first we have Unix that was initially started in 1969. Then the first edition was released, Unix time sharing system, and then it just, created more and more additions to it. But then as you go along, you see that it just starts to spread out to all these other operating systems that are coming from it, and this small window doesn't quite illustrate it, but there really is a lot of things that come from it. Windows was based upon this, Mac was based upon this, and this graph really just illustrates the widespread effect that this had on computing. So let's talk about how Unix works. So as we discussed before, the operating system exists between the hardware and the applications. I shouldn't say OS. So it exists between hardware and the applications, and this is where Unix lives. The operating system provides high-level abstractions to the users, such as files or directories. So if you just had, if you were just doing machine programming to the hardware, you wouldn't have these abstractions, but the operating system gives you these things that make it easier to work with a computer, such as files or directories, and it provides services such as multi-programming and various other things. So basically it makes our lives easier. So how many have heard the term Linux before? And now you guys have all heard the term Unix. So does anybody know what the difference between those is?
GUI?
Not necessarily. Kind of. Linux is just a flavor of Unix. So they actually are pretty much the same thing. So Linux is based on Unix, but the code or concepts may differ, may not be fully compliant with SUS. So that is the specification for what an operating system needs to follow to be a Unix compliant operating system. So a lot of times people base their code on this Unix kernel, but then they don't completely follow the specification. So it's a flavor of Unix, but it's not exactly that. And I think only this might not be 100% right, but I think only 7 languages actually follow the SUS specification, so not that many languages are Unix based. Alright, so any questions so far? Great. So then let's start talking about the shell. So what is the shell? Users typically interact with Unix via shell. A shell is a command line based environment for execution and control of programs, and there are many different shells, but a number of capabilities are common. So a shell is essentially this environment where you have a command line, you can enter commands in, it executes the commands, and you get a result back. And it's a very simple way to interact with the operating system. I like it a lot more than going through GUIs and things like that with Windows, for instance. Yeah, so there are many different shells, but a number of capabilities are common to all popular shells. So we have command execution, being able to type in a command and have it run immediately. Redirection of input and output, which is essentially capturing what a command produces or giving some set of information to a command as input. Piping, which is chaining multiple commands together so that they all use each other's input and output. Wildcard expansion, which is essentially being able to pattern match things, create regular expressions that let you encompass multiple names of files or things like that. And finally, process control, which is just being able to spawn processes and being able to manage what's going on with your computer. Oh, there's one more. Command recall and editing, which is essentially just being able to remember what commands have been executed and being able to modify them to do something different. Oh, there's one. I thought I'd lessened that. Oh, finally, this is an interesting point. Most popular shells are actually Turing complete. Does anybody here know what Turing complete means? Kind of says it up there, but essentially it means it can be used to write any program. So any concept that you can come up with can actually be written and performed in a shell environment. Yeah. So any questions? Great. So here we have just a screenshot of what a shell might look like. So a shell provides an interface with features and applications. The user enters a command on the terminal, and then the command executes. Commands produce a result based on the conditions of the environment or input given. So over here, I just have a simple Java program. This cat command prints it out on the terminal, and then Java C compiles the program. There's an error in it, and then Java would run the program. So right here, this just points it out. Cat is the command that we were running here, and here we're running the command Java C, and it's producing output on the terminal. It's telling us that it wasn't able to compile the file we wanted to compile. So, yeah. So essentially, commands take input, and based on the condition of the environment you're in, produces some output and performs some operation. So let's look at what shells are available. So there are many Unix shells, and here are some common ones. Bourne shell, C shell, which is actually, it's kind of an interesting environment because you're essentially, a lot of the commands you're entering and the things you're doing are very similar to C code on the command line. It's kind of weird though, so we won't really use it. TCSH, which is the enhanced C shell. The Corn shell, and the Born Again shell, which is shortened to Bash. And what this is it's basically a better version of the Bourne shell, more like wildcard expansion, more features as far as being able to customize it to make it your own. And this is the shell that we will be using in this class. It's very common. I think it's the default shell that you use on Lectura, which is the machine we'll be using. Yeah. And finally, Z shell. So there's a large variety of shells. Bash is probably one of the most common ones, but just know that these are out there. Yeah. So if you want to learn more about it, you can look at the Wikipedia page and read more about what kind of shells there are and what their different flavors are, I guess. And we'll be using Bash because it is widely used. It's a typical shell. There's not very much that's weird about it that you might not find in other shells. It's full featured, all those things I mentioned on the previous slide. It has, it's POSIX compliant, which essentially means that it's able to interact with any computer system. forget exactly what POSIX stands for, but it means that the shell is portable between computer systems and operating systems. Okay. Any questions so far? Great. So now let's talk about logging on to Lectura. So again, Lectura is the machine we'll be using in this course. It's posted here on campus at U of A, but you can connect to it anywhere in the world through a shell. So you can connect to it and develop on it, and in this course you guys might want to try and develop on your own laptops in your own environment, things like that. I suggest that you do not do that. I suggest that you do all of your development on Lectura, so that when we run your programs and grade them, it'll be in the same environment that you guys created them in, so it really just minimizes any errors that might be due to the environment you were working in. And here is a quick note: for 2 points of extra credit on the first assignment, you can log on to Lectura and run this following command. It will email you and it will email me a receipt saying that you ran it. Hold on to the receipt in case we forget to give you the points in the future, but you should run it, and then you'll see the following. You'll just type this into the prompt, you'll hit enter, it'll say executing, and then it'll say that you ran bash, or you ran the command successfully. So 2 free points, should take like 5 minutes to do, and then it just kind of gets you guys comfortable with logging on to Lectura and running a command and things like that. So you should probably do it. Another thing before we talk about actually logging on to Lectura is, because we'll be using the bash shell, again, you want to be developing in the same environment that we'll be grading in. So to make sure that you have that, you can head to this link right here, which is a link for the CS department's website. And there's a bunch of services here that you can do, and one of them is change my Unix shell, and then that'll tell you what shell you're already using, and if you're not using bash, I would suggest switching to it. And then it will also, on that page, you'll find a link to change your login password on Lectura. So if you guys should all have CS accounts already, being in this course, but if you've forgotten what your password is, you can go there and you can change it, so you'll actually be able to log into Lectura. And just so you guys know, your NetID password and your password on Lectura are not connected, so make sure you know what your actual password is. It won't be the same as your NetID unless you made it that one. So yeah, and if you log in, if you don't have a CS account and it's your first time ever creating one, when you log into Lectura, it'll ask you to enter a password, I believe. So yeah. All right, any questions so far? So if you use a Mac, logging onto Lectura should be fairly simple. You'll simply just open the terminal application, and then you'll use the SSH command to log on to Lectura. So here we have a terminal on a Mac, what it will look like. This is the bash prompt on your Mac. You'll just type the SSH command, and then you'll put your NetID at lec.cs.arizona.edu. So essentially you're telling it, you're saying, I want to connect to a remote server. You're giving it what your username on that server is, and then you're saying this is the server I want to connect to. And this @ sign is distinguishing between your username and the server you're connecting to. So once you hit enter, you should get a prompt like this right here, which will be asking you to enter your password for the account. There will be no echo or feedback, so you won't be able to tell what you're typing, but you will be typing something, and then once you hit enter, it'll verify that that's your correct password. And then once you are logged in, this will be the screen that's printed out when you log in, and then you'll have a command prompt and you'll be logged into Lectura. So yeah, it's fairly easy on a Mac. If you have a Linux operating system, it'll be the same exact thing. Just open up your terminal, run that same command. Real quick, how many people in here use Mac? How many people use Windows? Okay. And does anybody use Linux? Cool. So yeah. Now we'll talk about how to log into Lectura on Windows. So my preferred way to do it on Windows is to use this program called PuTTY. Does anybody have PuTTY already? Okay, great. So you guys probably know how to use it. But for anybody that doesn't, you'll just go, if you just Google for the PuTTY client, it'll be the first link that comes up. And you'll go to the page, and this is the file you'll want to download. And then I also have the link up there. You'll download it, you can install it, and then when you open PuTTY, you'll be presented with this window. And then to connect to Lectura, you will enter lectura.csarizona.edu into your host name, and that's really all you need to do. And then you can just click open, and it will open up a terminal window. And then once your terminal window is open, you will have a prompt that says log in as, which will enter your net ID. So you enter what that is, and then same thing as I was talking about before, it'll prompt you for your password. There'll be no echo or feedback on that. You'll type in your password, and if it's correct, you'll log in. So yeah, any questions on that? Great. So, a few other odds and ends about Lectura. You can have any number of login sessions open at once as you want. It doesn't limit you. If you accidentally ran a command that will not stop, or you want to stop it for whatever reason, you can just hit Control-C to quit it, to kill it. Once you're finished with your session on Lectura, you can type exit to log out of the system, and it will basically just log you out of Lectura. If you're running a different shell and you don't want to make bash your default, you can still just run the command bash, and it will open up a bash shell. Also, if you want to mess around with any of those other shells, I think Lectura has KCSH, which is the extended C shell, and one other one. So if you wanted to mess around with those, you could also just type their names in and enter it and see what they're like, and how working that environment is. So yeah. So does everybody understand how to log into Lectura and think they could do it now? Great. Then let's talk about the first assignment real quick. So obviously we haven't gotten super far into the material for the course, but this first assignment will be talking about the material we have this week, and it will be due Sunday night. So in the future, I had the assignments due Friday nights. But let me just ask real quick, would people prefer that it's due Friday nights or Sunday nights? Sunday nights? Okay. Then we'll change it so that all the assignments are due Sunday nights. This first one I had already had it on Sunday just because we were just jumping into the course and everything, but I'll change it so that all the other ones are on Sunday nights. And then all the assignments will be out a week before they're due, so I'll have the next assignment out, hopefully before, but definitely by Sunday night. So, let's see. So this assignment there's 3 Java programs that are really simple. They should be really easy to write. And then there's a bunch of like one-line bash commands that you guys will be writing. And then there's a question and answer portion that you guys will also be filling out. So you guys probably are really familiar with Eclipse or some development environment for Java. But I encourage you guys to use a text editor on Lectura to develop these programs. I can't enforce this, but the whole point of the class is that, or one of the points of the class is that you learn how to work in a Unix environment and develop in there. So I highly encourage you guys to use a text editor so that you gain an understanding of how that works. Again, the programs themselves should be short and simple, but learning to develop a new environment may be hard, so I encourage you guys to do that once we talk about it, hopefully on Wednesday. So right here we have any files pertaining to this assignment will be found at this link, CS www classes summer 17 352/AN, and that is a directory on Lectura. It's also the same as that course website I showed earlier. It's like, we're actually already there. Oops. So this website right here is actually the same as the directory that's on Lectura. So if I update any files on Lectura, you can see the changes reflected on this website. Let's see. We'll be using a utility on Lectura called turnin for all of our assignments. Essentially how it works is it's just a command where you give it a turnin name, and then you list out all the files you want to turn in. So for this assignment, it will be turnin 352 summer 17 underscore A1, and then the star just means all the files you want to turn in after it. So that's how we'll be turning in files. It's a fairly easy utility to use. If you guys have any issues with it, let me know. Yeah. So then let's go ahead and look at what these problems are. The first problem is called histogram.java. And so for all these problems, you'll be turning in a file that is named whatever that problem is called. So for instance, histogram.java, you'll develop on Lectura in a file called histogram.java, and that's where you'll write all your code in, and that's what you'll turn in. Same for all the rest of the problems. So this first one, you simply will be reading in input that is a stream of characters, and you should count how many occurrences of each characters there are, and then just print out a histogram of them. Shouldn't be too difficult, hopefully. Next, you'll have this program called cat.java, and cat is actually a command that is in the bash shell. So writing this program will hopefully give you a little bit of an understanding of how it works. So what this program will do is you'll be given a file name as an argument. So for instance, right here we're running it by saying java cat, and we're giving it the argument test. So test is the file name that we want it to read and print out. So if we run it like that, all it has to do is open up the file and print out all of its lines. Then you have to implement two options, which we'll probably get to and talk about today, for the command line. And what the options will do is we'll modify what the program prints out. So the -n option will tell the program to print out line numbers with each line. So like right here, we have java cat -n, and it just prints out these line numbers for each line. And then the other option you'll have to implement is -s, which removes consecutive white space in between lines. So for instance, right here we have 3 lines of white space. So when we use the -s option, we'll just be printing 1 line white space, and we condensing all of it. Yeah, so you'll be reading the file name in from the arguments, and you'll also have to check if any options are enabled. The options may come in any order, so be careful of that, and both the options may be enabled at the same time as well. The last Java program you're writing is called box.java, or sorry. Any questions on the first 2 programs so far? Great. The next program is called box.java, and this will just read in from standard input, and it will print a box around whatever it reads in. So the description of this is fairly simple. Hopefully implementation isn't hard either. Right here, if you ever see a tab character, you should change it to a string of 8 spaces. So that's because working with tabs can be kind of weird, but it's not a very good way to handle tab characters, but that's what we'll do. And then next we have a series of 1-line bash scripts. So I know we're not necessarily, you guys probably aren't super familiar with the idea of a command yet, but I just want to get this out here because it is due in less than a week, so you guys know what's going on with the assignment. So these will essentially be one-line bash scripts, which will be a sequence of commands that you guys will be writing to do simple tasks. Each one of these problems, you'll be pipelining commands together, which we talked about earlier. It's essentially just chaining commands together. So this first one will be called user count, and it will report how many unique users are currently logged into Lectura. Note how it says unique users. Some users may have multiple sessions, but you will just count that as one user. And then the next script will be Wednesday, which is kind of a weird name, but it'll just print out all the days of the month that are Wednesday for the current month. So for example, for June, if we say date, we'll see that that's the current date. And then if we say Wednesday, it prints out the 7th, the 14th, the 21st, and the 28th are days that will be Wednesdays. So we'll be writing a command that does that. RevSort will take a file name and a keyword from the argument list. You will then search the file on all lines containing the keyword, and once you have this list, you will sort them by the list character on each line. So essentially, right here we have this file called example, which has these 3 lines in it. So then, with the RevSort command, what you'll have to do is you'll have to take that file name, you'll take a string, and you'll have to search that file for that string, and you'll get a list of lines that have it, and then you'll only print out those lines in a reverse sorted order. So right here, this line and this line both have the pattern B in it, and then we print them out in a reverse sorted order. So that one can be kind of weird to wrap your head around, but I think you guys will be able to do it. Recent. For this problem, you'll write a one pipeline bash script that searches the current directory and prints the name of the most recently modified file. So we'll talk more about files so you guys will actually understand what this is doing later, but essentially you'll get a list of all the files in the current directory, and you want to print out the name of what the last modified file was. Yeah. Any questions so far on any of these? Great. Next one is called getRC. So for this problem, you'll write one pipeline bash script called getRC that outputs the value in a specified row and column in a file whose lines consist of comma-separated values. So hopefully everybody knows what a CSV is. Does everybody know what that is? Okay, I'll just talk about what it is. So a CSV, it's literally what it says up there, a comma-separated values file. So it's just a file that has a bunch of data in it that's separated by commas. So like this is the first row, this is the first row of the file, this is the first column, this is the second column, this is the third column, and each line is a new row. So what this command will do is it will be given a position that's separated by a comma right here, and then it will also be given a file name, and you'll have to pull whatever entry out of that file, whatever position you're given, you have to pull that entry out of that file. So for instance, this is the example file we're using, and we tell it to pull position 2 out, and it grabs this EE and prints it out. And then we tell it to get position 1, 3, it goes in the first row and gets the third column, so it brings C out. So hopefully you guys will be able to figure that one out. Yeah.
If the position isn't valid, do we not?
No. All the don't know if I say that, but we'll just test you on valid positions because it can be kind of weird to handle with just one line. The next command you'll have to write is called descend. So this just you will print out, as we saw before with the cat Java program, there's the -n option which would print out line numbers with each line. But for this command, you'll be essentially doing that same thing, except the line numbers will be descending rather than ascending. So however many line numbers are, that'll be the line number of the first line, then decrease by one, then decrease. But you'll be just writing this as one command for that. So yeah. So essentially here we have this file that has these 4 lines, and then we say descend that file, and it just says 4, 3, 2, 1 in each line. Hopefully everybody gets that. And then finally, the last problem, it's a problem containing more problems. It's like a nesting dolls, you know? So we have, it's called questions.txt. So over here, if you go to the course website and you go into the A1 directory right here, there's this file called questions.txt. And if you open it up, there's 10 questions, I believe, in here. Probably won't be able to answer them until the end of this week, but just so you know that this is here, and it's just simple questions, and you will write your answer on the line that starts with an A, and yeah. So this whole thing's worth 10 points, so each one of these will be worth 1 point towards the grade for this problem. And finally, in the future, for this assignment and for the future, output from your submitted problems must match exactly as described or shown in the spec. I don't mean to be ambiguous with anything. If there's ever any ambiguity from the spec, or you're not sure about how something should work, please post on Piazza and let me know, because that's probably my mistake, and I probably was not intentional. So I'll want to fix that as soon as possible. And yeah, then just don't cheat, which hopefully you guys all know. So that's the first assignment. I just wanted to put that out there so you guys have an understanding of what's going on, that you know what to do at the end of the week, even though you might not know exactly how to do it at this point. So, any questions about that? Great. So let's start talking about commands then. So a command is how we tell the shell what to do. You're given a prompt, and then you have a command that you write out, and then you enter it, and it will do something based on what arguments you give it or what the state of the environment is. Each command has a single task it does, but this task can be modified slightly by using an option. So like we saw on the assignment, there's that cat program that you'll be writing, so that's actually a command that you can do. So the cat command just prints out the contents of a file. However, you can give it these options that slightly modify what it does, like -n will give it line numbers and things like that. So the syntax for a command generally follows the command, whatever options you want to use, and then the arguments you're giving the command. However, often options can follow the arguments and it will work fine. I believe you can usually do the command options, whatever argument you want, then options, but it's really depends on the command how exactly it works. So if you follow this syntax all the time though, it should always work. Commands exhibit the silence is golden rule, so if nothing happened, it probably worked. So for instance, for the command to compile a Java program is called javac. So if you say javac and give it some file name, if it doesn't say anything, that means the file compiled successfully. But then if there was an error in the program, it'll spit something out saying, you know, whatever line number this error. So most commands follow this silence is golden rule. Yeah. So that covers that. So again, to execute a command, we type it into the command prompt and hit enter to run it. If there's any output, it is displayed on the screen. So here we have this command, who am I? So this will just print out whatever user is currently logged into the terminal. So we say who am I, and it prints out dpdickon, which is my username. Another command is called date, which just prints out what the current date is. So if we say date, it'll print out Monday, June 12th. That's this morning. So yeah, another command is pwd, which prints out the working directory. So this prints out that I was in /home/dpdickens/temp. Let's see. True. So this is a command. It's literally just giving the terminal or the shell the state true, and so it doesn't do anything. So no output's given. This isn't a built-in command, but it's just some stupid command I wrote that comes up with a random band name. So there's plenty of things you can do here. So essentially all you'll be doing to interact with the shell is just giving it some command, hitting enter, and it will give you a result. So let's talk about some arguments. So again, arguments are what a command operates on. So here we have the calendar command, which you give it a date, or you give it a month number that you want to look at, and the year that you want to look at it for. So here we say calendar 9/2018, which this is not the right date, but that's what it prints. Yeah, I think that's wrong. Anyway, so here we're just giving it these arguments right here. This is the year you want, this is the month you want out of the year, and then it prints it out for you. Next, we have echo. So echo is a fairly often used command to complete various tasks, and all it does is it just prints out the string that you give it. So echo hello world would just print out hello world. Finally, there's this other command called factor, which just factors out whatever number you give it. So if we give it 27, it says 3, 3, and 3. So many times, a lot of commands, the arguments you give it are file names. So we talked about this a lot already. The cat command, this just prints out the contents of whatever file you give it. So if we say cat and then we give it test.txt, this will print out hello world, and that was the contents of the file. Next, we're trying to compile a Java program here, and we give it the Java file that we want to compile. So we say javac hello.java. This has the silence is golden, it said nothing, so it worked successfully. And now we've created a class file in our directory, and we can say java hello to run the program, and it will open up the class file and will run it for us. So when we run java hello, it runs our hello class and it prints out hello. So rm is the remove command, and what this does is it deletes a file that you give it, the file name that you give it, it will delete. You can give it multiple arguments, multiple file names after it if you want. Yeah. So now we remove the Java class, and then when we try to run Java hello again, we get an error that we could not find or load the class. So, yeah. So a lot of times the point of this slide is just that a lot of times the arguments you'll be dealing with are file names. fgrep is a command that you'll use a lot. So we're going to use fgrep because, for some reasons I'll discuss in a minute, but there's actually a family of grep commands. There's like fgrep, I think there's ggrep, there's just normal grep. There's a lot of different things. So, but what this does is it searches for a pattern in a given file. So the first argument is the pattern to search for, followed by what files to look in. So here we have fgrep hello in test.txt, which is that same file we were just looking at, and it prints out whatever lines match with that pattern we gave it. So here we see fgrep hello, and it just prints out that one line. Here we do the same thing, but we give it multiple file names, and we get out a few more lines now. We have test.txt, hello appeared there, and hello.java we have public class hello appeared, and we also have this print line that appeared that contained the string hello. So finally, if there's a pattern that it doesn't match, this command's actually going to be silent. So we say fgrep error in hello.java, that doesn't appear anywhere in there, and it's not going to report anything. So do you guys think fgrep exhibits silence is golden? Why not?
It sounds like you say it's positive outcome.
Right, yeah. So when it's a positive outcome, it's going to print something, right? But when it's a negative, it's not going to print anything. So it doesn't, some commands, like I said before, don't follow the silence is golden rule, like fgrep. So, any questions so far about arguments or fgrep or anything? So like I said, there's a family of grep commands. We'll start with fgrep, and we're just going to use this because I mentioned earlier that Bash has pattern matching and meta characters that you can use to match multiple things. Fgrep does not consider these meta characters in whatever pattern you give it. So if you're just starting out, it's a little bit safer to use, I guess, so that you don't get results that you're not looking for without knowing, because you might not know what those meta characters are doing in there. So just stick with fgrep for now if you're doing something with that. So then let's start to talk about options. So many commands allow options which adjust the behavior of what the command does. Options will always begin with a dash, and then we just have some examples. So we have the date command, which prints out what date it is, and then if we give it the dash U, it'll print out the UTC time zone rather than the MST time zone. WC, this command is called WC, but it stands for word count. So typically when you use it, it gives you a report of how many lines there are in the program, how many actual words were in the program, and then the byte count of the file. So we can then use multiple options on it. So we say -L -W. So what do you guys think that this is printing out now?
The lines and the words.
Yeah, just the lines and the words. And so then, what do you think the option would be if we just wanted to print out the bytes? Yeah, -B. So, a lot of these options can be intuitive. If you guys are curious about what options are for a command, let's see. You can actually, there's these things called man pages, which let you look at a command, see what it does, and explore what kind of options it might have associated with it. So, for instance, if we wanted to look at word count and see what options it has and just figure out what it does, we can say man word count, and we'll pull up this page. We see that it prints new line, word, and byte counts for each file. And then in here, we see all the different options that are associated with it. So, yeah. Any questions so far? Great. Well, I'm going to be honest with you guys. We got a lot farther today than I expected. So, I know it's 12 o'clock. We have another half hour. But if you want, we can just call it today. Sweet. Well, thank you guys all for coming. I hope you're excited for the class, and I'll see you guys tomorrow.